Hello everyone, myself Vasudevan, M.Pharm Assistant Professor in Department of Pharmaceutics, Sri Shanmugha College of Pharmacy, Sangagiri, Salem. Today, discuss about the size reduction. The size reduction is the one of the very important topic of pharmaceutical engineering subject. This is the B Pharm third semester of first unit chapter. The size reduction in pharmaceutical engineering, the exploring the industrial process of transformation of raw material into the pharmaceutical useful product or the mechanical size reduction of technique. The most of the material is starting is the very like a large particle. They are easily converted into the small particles. The various mechanism used in this method. What are the methods used in following topics? First of all, the define size reduction. What is the size reduction? The size reduction transforms the large particle converted into the small particle through the mechanical means like as the comminution, grinding or milling, reduction, some cracking, something. The process of categories two type of one is the solid, another one is a liquid. The solid process is the grinding and cutting, and the liquid uses emulsification and automation. These are of the process of categories. And what are the matters? What are the matters including this? Why size reduction is very important? First of all, this is surface area. It's a uniformity. Increase the surface area, better dissolution and absorption. First point. And second point is the dosage form. Mainly thing is the dosage calculation. The capsule, insufflation, ointment, record partition. Below the 60 micrometer is the very important. So the particle converted easily. They are used for the dosage form conversion. Another one is the therapeutically effect. The small particles are enhanced to the drug effectiveness and bioavailability. Another one is a uniform mixing. The mixing process is very important. Why? Because various size is not mixed properly. So the uniform size is very important. The uniform mixing go through the particles. The size reduction is converted into the large particle to small particle. Another one is suspension. The fine particle reduce the sedimentation rate of the pharmaceutical suspension. Suspension formation, emulsion, like most of the pharmaceutical preparation, the size reduction process is very mandatory. The mechanism. What are the mechanism involved in this size reduction? The mainly four important mechanism. The first one is impact, and second one is compression, and third one is cutting, and fourth one attraction. The impact is the high efficiency and low forces timing. The high speed and hammering brittle materials. They are used the high impact sources. And the compression is the crushing two or more ball or roller something. Crushed, sorry, like one particle large particle, some interaction between the rollers, those the large particle, some interaction to the balls, so they are large particle converted into the small particles. And attraction, some scraping fine grinding, large solid particles converted into the large items. They are grinding, some forces involved in the grinding mechanism, so they are easily separated to the small particle. And cutting, some instruments are used in the blade mechanism. They are cutting the large particle, like various mechanism, various particles involved in the cutting process. The four core mechanism, different material require different approaches. Impact or brittle materials, compression, hand substance and cutting, fibrous material and attrition grinding. They are all of the mechanism of size reduction. And what are the theories involved in this size reduction? What are the theories involved in? First one is Griffin theory. The Griffin theory, Kick's law, Rittinger law, and Bond's law. The Griffin theory is a force record that depends on the crack and length of material. The Kick's law is the work is constant for the same reduction ratio regardless of original sizes. And the Ringer's law is the work is proportional to the new surface area produced. And Bond law is the work is proportional to the square root of particle diameter. These are all of the theories of covering in size reduction areas. Hmm. What are the factors affecting in the size reduction? First of all, factors affecting to the some disadvantage for the size reduction. First one is hardness. Hardness is a very difficult factors. Why? Because the hardness is the not easily converted into the small particle. So the soft material break the easily than harder ones. Why? The hammer will or the will for iodine, the first one. And second one is fiber nature. Fiber nature material is not converted easily for the small particles, because they are one of the factors of affecting for the size reduction. Though the material like Raoulfia and ginger records cutters instead the impact. Why? Because they are most of the fiber inside of the material, so they are not easily converted to the small size particles. And elastic and sticky product also one of the factor for size reduction, like example of the gum, waxes, resins, soft during milling, though they are chilling before processing helps. So they are one of the mechanism, sorry, factors affecting. Another one is melting point. Melting point also very important factor. Wax substance required to the cooling to prevent the softening from the heat generated. And another one factors is hydroscopic. The material like the potassium carbonate absorb moisture, use the closed system like the porcelain ball mills. So these are of the factors affecting the size reduction: hardness, fibrous material, elasticity, and melting point, hydrogen. The other factors, some factors are reductions, size reduction affecting. Okay, one of the most of the very important instrument is the hammer mill. This is a familiar one. This the instruments installed in the all the small scale, large scale industry. The principle is the impact mechanism. They are between the rapidly moving the hammers and the rotator and stationary power material. The operation procedure is the hammer swing is 1000 to 2500 rpm per minute. The speed rotation is the 1000 rpm. Maximum speed is the 10,000 rpm. The material entered through the hopper. The first of all, the material enter into the hopper. They are pulverized the hammer and places through the screen, and the fine powder is collected the end of the bottom of the mill. The best for the main advantage is the brighter material. The impact with the blunt hammers and the fibrous materials, they are cutting edges. So most of the some materials used is the hammer mills. And second, these are of the one of the very important size reduction instrument. The ball mills is the principle of it, it's also impact mechanism and attrition mechanism. The between the rapidly moving the balls, the powder in rotating hollow and cylindrical method. The key features of the balls occupy 30 to 50% mill volume. Overall the volume is 100. The balls occupied only 30 to 50 percentage mill. That's a very low speed. It's a attrition means at the correct speed, it's a cascade action. And what's the wet and drying grinding. What are the uses for this instrument for the material? The stainless steel mills prepared for the ophthalmic and the parallel product. Ophthalmic and parallel, but low speed milling and dyes, pigmentation, and insecticide. These all of the ball mills are the procedures. Unspecified some mills are involved in this size reduction mechanism. The edge runner mill, end runner mill, and fluidized energy mill. So first one is the edge runner mill. The instrument diagram is the two side is the miller and center side is the crack shaft. The heavy stone rollers are crushed middle on the granite bed. And the ideal of granite is to the material of the fine powder. And the end runner also same similar as the edge runner mill. The mechanical motor and pistons, the dump belt, the saved piston, the revolving the rotating motor. The handles fibrous materials are wet grinding. And another one is the fluid energy mill. The fluid energy mill, high pressure and air creates the turbulence for the impact, and attraction reduces particles 1 to 20 microns, perfect for the heat sensitive material like as the antibiotics. Okay. Overall, the key tax were the size reduction essential. They increase the surface area, improve the therapeutic effectiveness, and enables the proper dosage from the preparation. The multiple mechanism exist: the impact, compression, cutting, and attraction. Each suit the different material types. The mill selection matters to choose the based on the material properties, hardness and fibrous nature, melting point, and hydroscopicity. And the final advantages of each mill: from the hammer mill, bridal material; from the fluid energy mill, to heat sensitive substance. Okay, these all of the overall key points of the size reduction material. Okay, thank you. These following all the slides for the size reduction. This is very important for the pharmaceutical engineering subject in BPharm third semester. Okay, we are discuss about another one topic. It's next video. Thank you so much.